We've already got people coming in.
Mhm.
Welcome, welcome.
Hi, everyone. We'll get started in a few moments. And welcome to today's Why session.
Okay, we'll just give it a few minutes for people to come in, and then we'll begin.
God, there are a lot of people in here. Wow.
Oh, goodness.
Welcome,
Yeah, I
everyone.
guess if you're just waiting now, I guess we can introduce like ACM in general.
Yeah.
Oh, we didn't put the ACM link.
Well, let me go ahead and introduce that it's one of our WISE workshops.
Oh, yes, I'm sorry.
Yeah.
Because
Okay.
we have a check-in code, but then it's like, what does that mean? It's like, oh,
Yeah.
it's just
Also true.
Okay. Well, welcome, everyone. We're going to go ahead and start. My name is Alejandra Arguez. I'm one of the program coordinators at the Ideas Center. Today, you are attending our Y session focused on Python. So you will hear from ACM, and they'll definitely share more about what the organization is, as well as what the acronym stands for. You will hear about Introduction to Python Basics, and this will be recorded and posted on our YouTube channel within the next few weeks. Feel free to be active in the chat as well as the Q&A. In the meantime, I'll go ahead and pass it on over to Kyle and Chris.
hello there.
Yeah. Hello, everybody. Glad get to see so many people have come out to learn from us. That is very exciting. So yeah, we're ACM. If you don't know who we are, that stands for the Association for Computing Machinery. We're UCSD's local chapter, and we essentially hold a lot of community-based sort of events around sort of computing thing. And well, today we're going to teach you all about Python. And if you're wondering what the check-in code is in the top left corner, if you don't know, if you're not familiar with how our events kind of go, so we have a membership portal. Chris, if you can just link that in the chat, that'd be really helpful. But yeah, we have a membership portal where if people show up to our events, they can use check-in codes to check into our events, and they get points, and it's all really cool and stuff. So those points don't do anything as of right now, but we're working on a store that'll come out when COVID is no longer a thing, we hope. But yeah, if you'd like to check into the event, use the code wiseup in the top left on the slide here, and you'll get points for that. Also, if you would like to follow along with these slides, I have posted the link to these slides right here. So feel free to go there if you want to look at the slides.
Okay, so I guess we have had enough time for people to trickle in. So
yeah.
We have a membership portal for ACM, and if you decide you wanted to get a little more into our organization, we have a point system, which is purely cosmetic as of now, but it's a fun little system we have to encourage people to come to events. Hello there. I see all of you in chat. I would also like to encourage that if you have any questions, please post them in the chat or in the Q&A, and we will do our best to answer. Let's see. Okay, let's go.
All right. Yeah. Oh, okay. Yes.
Only one of us has control over the slides, and it is not me.
Yeah, my bad.
I think generally this event is made for, well, engineers who have never programmed before, mainly because like programming is a pretty cool skill, and it's becoming pretty important. If you're like, the field of computer science is quite large and integrated into a lot of, say, engineering fields. So what you should get out of this is you should get a good foundation of just programming in general, like understanding variables, learning how to use comparisons and conditionals, creating functions, and then at the end, making simple programs. Hopefully after this event, you will be able to go on your own and, create things that you think are interesting, or just small projects that are cool. And hopefully you will be able to go on your own and learn even more. Next slide. So we have two real methods for using Python. The main one would be to download it, install it on your computer, but that takes time and is something that you should probably do after the event. We have, let me link the thing in the chat. We have there is an online interpreter for Python where you can type stuff in and run it and see it run in real time. So I would encourage all of you. I just put in the chat to open a tab and start exploring. Is there a check-in code? There is a check-in code. Let me put it back in the chat. You don't have to move. It's right here. wiseup with a 1 because we're hacker language things. What is it called? There's a term for it where you put numbers instead of letters. Anyways, let's continue. Next slide. So the general Python terminal should look something like this if you ever wanted to download it. You can also create text files and put stuff in. For what we're doing, we're going to be using the online interpreter. So next slide. Should look a little something like, I don't think the link's set in the chat. Oh, if you came back a little later. All panelists, and I sent the things into the wrong chat. I'm going to cry. Anyways, there are the two links we put, the ACM member portal and our slides, acmurl.com/wisepython. And then we also have our code wiseup. So this is what our terminal should look like, at least for the online interpreter. You put something on the left and then you run it at the top and you should see a result at the side. So if you would like to, next slide, we should be able to see, or actually, we're going to talk about why we decided to pick Python. Python is fundamentally very easy to learn and very easy to understand. If we put code, even to most people who have never seen code before, if we show a snippet of Python, most people are able to understand it because it is very similar to how we speak and how we understand language. Grammatically, it is very similar to like just how we speak. As well as that, it is extremely popular and extremely versatile in what it can do, and has widespread support from many facets of the industry. Many like fields of computer science use it, and it's pretty hip. You don't have to deal with all the gross archaic stuff. I saw Kyle like shake his head, but it is very widespread and interesting to use. So that's typically why we chose it, and it's very easy for beginners to learn. So yeah.
We have to bring up the poll.
Oh, the poll. Yes, let us begin the poll. Loud polling. Allow panelists to vote. Sure, why not? So I guess at this point we want to ask, how much programming experience have you all had? Oh geez, we have a pretty even spread. Oh no, never mind. I'm not sure if you guys will be able to see the results. Right now, it is essentially all three answers have the same amount of votes. Goodness. Okay, so we'll just, don't worry. We'll still like, I guess we'll still continue as planned. We just wanted to get a nice sense of like how you all, yeah, okay, there it is. How you all, what experience you had. Let's see, share results. Yeah. Okay, next slide. So most, when you learn a programming language, most people teach Hello World. It's a very simple program that'll allow you to just send a message to the terminal. Here's Python's equivalent of it. As I said before, it's very easy to understand. You have a print statement, or if you go to the next slide, you have your string, which is essentially your text, and then the next slide you have your function. Yeah, that's about it. Let's continue. When we have, I think one of the difficult things to understand about, or one of the things that people get stuck on very early on is how data is stored in programming languages. It's a little different than what most people would think in terms of like, because of how they like deal with, it's a bit different than what most people are familiar with. Normally we like when we have an item like an object, you can't just copy it or you can't just like duplicate it. But then in programming language, we have that like accessibility, I guess. So in general, we use variables in order to store data, and then we can store a variety of data, which we'll go over in a bit. There are booleans, integers, strings, and floats, which we'll get into later. To create a variable in Python, you literally just name your variable, put an equal sign operator, and then whatever you want to store. Python is a language that automatically does the data type for you. So you can literally just do it like this, like a math class where it's like, oh, x equals 7, whatever you want. Next slide.
I want to quickly add that this equal sign is not an equal sign in the traditional sense in like math. This equal sign is what we call an assignment operator. So instead of saying a is equal to the value false, we assign the value false to a. I realize that sounds like a really subtle difference, but it'll like become clear as to why that's different later.
Okay, so what can we do with these variables? Well, as you saw before in our print statement, we used directly a string. When we have variables, we're able to interplace them with, well, our variables. So instead of needing to expressly like state what a variable is or what you want to print, you can store it and then print it. Or you can like print it 1,000 times if you wanted to, just using the same variable. Yeah. If you wanted to, you can experiment a little bit. Let's continue to the next slide. There are naming schemes as well. Typically, when we name things in programming languages, we want things to be consistent so that when people read your code, it's very understandable. So typically, the way it works is people capitalize or don't capitalize the first word in your sequence, and then they capitalize the ones after it, to any length. And also we can shorten it. This is kind of like just a naming scheme people do. If you wonder why they do it, it's just tradition, I guess. And it varies between people and places, and like, I guess even like just what language you use. This is a question that we are not fit to answer, I guess. Kyle, do you have any input? You a Haskell master?
What was the question? Sorry.
I mean, it's like camel case. Where did camel case come from again? I don't remember.
I'm actually not too sure. It's more commonly used in Java.
Mhm.
But I think a lot of people people who write Python or C code do underscores between separate words as well.
Yes.
It
Yeah.
doesn't
So
really
if
matter
you,
what you choose, but as long as you're consistent and your code is readable, then you're good.
yes. Okay. Next slide. This is where the importance of the operator or assignment operator comes into play. So like, let's say we can set a equals 4, b equals 8. Then you can assign a to equal b. This isn't like a math class where this isn't like mathematics where we're saying that a is equal to b. We're reassigning a to be equal to what b is. So when we actually print a, we get 8. And then this is the type of like situation where things are a little confusing for people who have never coded before, but it's pretty easy to understand. We are just replacing the value essentially. If you think about it like a little whiteboard or something like that, and it said 4 on it, then we essentially, when we get to a equals b, we replace a with what is said on b, and then we can print a as 8. No questions yet, so I'm gonna assume we're doing an okay job. The next slide. So in Python, we have 4 different data types. We have Booleans, which are just true and false. We have integers, which store whole numbers. So any number that just doesn't have decimals, you can store as an integer. Floats are numbers that have decimals or exponents. The reason why we have floats is because we can do some pretty interesting math to store data accurately to an extent. If you've taken like chemistry or physics and you know what sig figs are, or significant figures, that's essentially how floats work. And they're just for really small or really large numbers. And then last, we have strings, which is sequences of characters, like words. You can, the difference between, the one thing special about strings is that you have to enclose your string in apostrophes or quotation marks. And the reason being is like in our past example, we had A equals B. But how do you signify that like you want A to equal the letter B and not the variable B? And you can do that using apostrophes or quotation marks. We can go through the next like 4 slides really quickly. It's like, oh, when would you use Booleans? You want to store very small, like just true or false statements, essentially, just like flags. Are they a student? Are they a teacher? You know, are they over 21? Or like you can quickly just store these values. Next slide. Integers, just numbers, you know, it's like they can be very specific. If you know what an integer overflow is, it's where a number gets too big and your computer can't like store it. Python has ways. Python is one of the languages that has circumventions for that. I guess we don't have to get into it because it's like it's a very rare use case for most people. So just know that you can go extremely big with these numbers. You know, it's not something that would break specifically in Python. Next slide. We have floats. Same thing. We typically use it for decimal numbers, but they can, the same property holds. On the next slide, strings, we sequences of characters essentially. Just know that like I think this is kind of confusing for some people, but you can use quotation marks or apostrophes. It doesn't matter, they're interchangeable as long as they're not in the same line. So you can't start with an apostrophe and end with a quotation mark. Next slide. Here we have math operators like usual. If you've ever used like an online calculator, it's pretty similar. You know, you assign your variables and then you can do a plus b and you get your result. Here again, we have integer assignment where we set b equal to 2, then a plus b equals 5. We are very flexible with how we can assign our variables so that we can use the same code essentially to do multiple things. Then we have multiplication, addition, and then I think another important thing to note is how like parentheses work. PEMDAS is not a thing in Python. It goes left to right. So if you want if you want to make sure that your numbers are going in this correct order, you have to use parentheses. Like you gotta. And I think for most math, you should always use parentheses to make sure that there's no inconsistencies. But just remember for Python, it's very important. Oh, wait. Let's see. Some people ask questions. How would you work with biodata genomics, for example? With like bioinformatics and those types of things, you're working with a lot of typically you have external like files that are just long strings of like whatever data you need. So like a sequence of like DNA is just a long string of like the 4 characters. We can interpret that. We'll get into that later. That's a bit more when we get to data structure, like arrays and stuff like that. And then we can like give examples from there. And the other question was, will there be another workshop to continue this lesson? We do plan on having another workshop next quarter, I believe, Kyle.
Perhaps. I'm not too sure about that.
Yes, that
we have talked about that.
We have talked about it. If not, we will link more material. We are linking more material at the end of the slides where you can go on your own and find more materials and practice on your own. Honestly, if you get to the point where you want to program more, the best way to learn more is to do projects that you think are interesting. You learn a lot trying to explore new things. Okay, we've answered both questions. Let's continue. So we have 2 more operators here that are different than what most people have. Well, the first one is pretty simple. 2 asterisks give you an exponent symbol. So 3 to the 2nd power gives you 9. 4 to the second power gives you 16. Pretty simple. That's, if you've worked at the online calculator, you've probably had to deal with these like notation. The next one is something that most people never use, but we as computer scientists use a lot. It's the modulo. If you want to think about it, it's like if you have two numbers and you divide them, you end up with a remainder a lot of the time. And the modulo gives you the remainder. So let's say you have 5 divided by 2, or 5 divided by 2 gives you 2.5. But if you do 5 modulo 2, you get 1, because you divide 5 by 2 in long division, you get a remainder of 1. Why do we need this? There are a lot of cases where we can find, like, one of the big ones is, you can find odd numbers. If you modulo something by 2 and you get a 1, it's an odd number. But there are a lot of properties like that where we can use it to interesting results. Next slide, I guess. If you have a variable, you can use the class, or you can use the function type in order to see what it is. So if you just want to like test something out, or you need to make sure that something is a certain variable, you can check the type. This is just for amusement, I guess. And then lastly, we can use, if you want user input, you can use the input command to get user input and store them in variables. Or you can store them directly and use them directly, but in this example, we're storing them in a value. So when you use the input command, it prints whatever is in the parameters, and then it waits at the terminal for you to type it in. And then you press enter, and then it accepts it, and then it stores whatever you typed in into value. And you might note in our print statements, we have an F at the beginning before the apostrophe. That means we're using formatting, essentially. We're formatting the value, or we're formatting the things so that the strings, so that the things in brackets will get printed as their actual item. So you say you entered value and its type is type value. Then it'll automatically fill that in with the variable value, and also the function type, and then the item value. We have an example. We put in the link in the slides. Actually, let me put this in the notes as well. There. So now if you want to like experiment a little bit, you can run it in your terminal, and you can type in some item and check what value it is. If you put in like a number, it'll automatically store that as a number, and you can see its type is there. Let's see. Okay, next slide, I guess. Does anyone have a question yet? I'm kind of rambling. I'm sorry, but this is if any of you have questions, I really ask that it's really important that you ask, because this is the type of thing where if you don't understand something at the beginning, your foundation is not very strong. And like, it's the type of thing where you have Swiss cheese knowledge. There are a lot of holes, and things cannot stand on top, because like if there's something you don't understand, then like it fundamentally breaks anything you learn in the future. Any questions? I'll give it like a few moments. I think we're good. Putting it together, I have another just simple program we have here that takes in the few of the concepts we've learned before. We have our variables, which we're storing. We have our math functions, which we use to calculate essentially the quadratic equation, and then we're able to print it using our print statements and our formatted print statements. Let's see. This is also, I think, a great exercise, honestly, is finding interesting mathematical formulas and then trying to turn them into code. A lot of the times it is like, it forces you to try to look for things that like you normally wouldn't when you're coding, like how to say like derive pi. There are lots of like series and like ways of getting that number. And you can like honestly put them in code and do it for you. And it's a pretty interesting experience if any of you ever want to try that. Okay, we're gonna go to the next slide. While we did have a bunch of names and variables in our previous things, or previous slides, there are some reserved keywords that we can't use. Essentially, if you look at any of these like words, just don't use them like when you're naming variables, because it won't let you. Like you'll have an error when you try to run it. You can't name your variable true because it'll cause because you'll be setting, it essentially says you're assigning true to something else, which you can't do. These are all very important. We'll get to quite a bit of these in a few moments. Actually, I might be passing the baton to Kyle now. You ready? Okay. So yeah.
Sounds good. All right. So yeah, like Chris said, don't use any of these words when you're naming your variables, because these are evaluated by the Python interpreter as actual keywords that mean other stuff. So that'll mess up your programs. And I'm just gonna move on. Oh, we have one question. When I tried the input example for the int, it reported as class string. Why is that? I can talk about that. Yeah, sure. So I can go back to that slide real quick.
I forgot that I made a trick because I was.
Okay. So what essentially is going on here is that input will always take a string as input. So value, no matter what sort of thing you enter into the terminal, will always be interpreted as a string by the function input. What you can do to kind of fix that is you can do what's called typecasting. So if you wanted to say have number be an integer, right? You would basically encase input inside like another function, and then just call like call int. So you'd surround input with like int bracket, and then that would cast whatever the input is to an integer, or would try to anyway. Yeah, you can mess around with that if you'd like, but yeah, that's basically how you would. You can do this with any other type as well. So say you wanted to convert something to a float, you could do that as well in the same method that I just described. But yeah, feel free to mess around with that. Anyway, I'm gonna go back to where I was. Okay, so let's talk about conditionals. So we've talked about how like what like we've talked about variables and what how to like store data in a program, but ideally what we want our programs to do is we want them to be kind of smart. We want them to be able to make decisions based on sort of the data that's available to us. So that's what this if elif else blocks do. So these are comments, by the way. These hashtags, they don't actually do anything, but they're just there to sort of indicate like what, just to like describe what should be there. But yeah, these lines don't actually do anything. They're just there to kind of sort of explain to programmers like what should be there. So basically how an if statement works is that you do if, and something will be some sort of condition. And what we mean by condition is any expression that evaluates to true or false. So if something is true, we go into this first, we do the first thing, and then we ignore everything else that's below it. Otherwise, if this something evaluates to false, we go on to the next block, and then we do elif, which is short for else if. Else if some other condition, and if that evaluates to true, we enter the second block, do the other thing, and then we exit out, ignoring the else. If both something and something else are false, then we enter the else block, and then we just execute whatever's in here, and then we exit out. So yeah, that's how that works. That's probably a lot if you haven't like coded before. So if you have any questions about that, please put it in chat. Otherwise, I'm going to move on. Oh, another thing to note, this is actually the first part where we have to worry about how we format our code. So Python is really sort of the Python interpreter is kind of a stickler for like what your code should look like. because it uses indentation to figure out what if code is part of a particular like block or not. So you can see on the slide before that we've actually indented each of these comments. Any code that you write inside of if blocks or any other like semantic block that will there are more of these types of things that we'll cover later, but you have to indent them, otherwise the interpreter will throw an error and it will be very angry. So yeah, just remember to indent. That is hit tab or hit like however many spaces as long as you're consistent. But yeah, just remember to keep your indentation consistent. You have to write clean code. That's good about Python. Anyway. So I talked about conditionals before. I've talked about conditions before, but how do we actually write them? Well, Python has a bunch of different operators that allow you to compare two variables or two values, and they will return true or false depending on whether they are true or false. So here you can see we have we have a few operators that do that. So we have double equals, which is not the same as one equals. So remember, one equals is assignment. We assign a value on the right to a variable on the left. But here instead we compare the values of the variables on the left and right hand side. So what this basically does is that say you're comparing two numbers. If the left number is equal to the right number, then it returns true. Otherwise, it returns false. Everything else is honestly kind of self-explanatory in the same way. So we have less than. So if the left number is less than the right number, then it returns true. Otherwise, it returns false. Greater than, same thing, but flipped. Then you have greater than equal, less than equal to, and greater than equal to. If you've done math, then that's basically how those work. There's also is and not. Those are also valid comparisons. It's the cool thing about these is that you can basically just write a condition that looks kind of like English. So if you have a Boolean variable, you can say like if not thing, and then that'll be like if not. So not basically negates the Boolean, right? So it flips true to false and false to true. Is also a comparison operator. So it's kind of like the double equals, but not really. It's slightly different in that it's kind of beyond the scope of what we want to talk about today. But think of it for now as just another doing a similar thing to the double equals. But there are differences, and if you want to ask about that, I can talk about it. But otherwise, we're not really going to cover it today, and I'm going to move on. All right, so this is just a demonstration of what the comparison operators do. So here we have two variables a, b. We set a to 3 and b to 2. And if we compare a and b, you can see it returns false. So 3 is not equal to 2, so we have false. Here we have b is equal to 2, and we set b to 2 earlier, so 2 is equal to 2, so that's true. We have a greater than, we check whether a is greater than b here, and well, 3 is greater than 2, so that's true. Is 3 less than, on the next line, is 3 less than 3? No, so false. And 3 is less than or equal to 3, so that's true. Yeah, you get the idea. And here's just an example of how we would use an if statement. So this is just kind of a simple like toy example. Here we're taking a value, a variable age, and we're checking to see, and we're like treating it as an age of a person and seeing like what category the person fits under. So if age is less than or equal to 5, we print toddler. So that's the age is between 0 and 5, including 5. And then if the age is less than 12, so we know that the age is not between 0 and 5 if we skip this first part. But if the age is between 5 and 12, then we say that the person is a child. Else, if the age is less than or equal to 18, so if the person is between the ages 13, so that's 12 plus 1, and 18, then that person is a teenager. Otherwise, if we do not fit under any of these categories, we print adult. So yeah, you can mess around with this code if you want to. The link is over here. We have a question. Let's take a look. Are you limited to only one thing for each if else condition? Oh, I forgot to add things for this, but no, you are not limited to one thing for each if-else condition. But, well, the answer is technically yes and no. You could put multiple sort of comparisons in the after the if, but you have to combine them with either or and. I forgot to add that, but essentially, what you can do is that you can say if this expression or this expression is true, and it's literally just the word or. That's Python. It's English. If this expression or this expression, then you can enter the thing, and otherwise do something else. Or you could do if this expression and this other expression, then do the thing. So yeah, hopefully that makes sense. And feel free to mess around with that if you would like. Yeah. Anything else in chat? Okay, thank you, Chris, for putting that in chat. That's helpful. Anyway, I'm gonna move on now. So now we get into arrays. So sometimes what we want to do is we have a lot of data in one place, and we want to be able to do something with all of that data. So an array is basically a list of values. So here we have numbers, which is an array of integers. And we can access specific elements of that array using indexes. So each array, every array is going to have a list of numbers or a list of some values, and we can access those particular values using an index. So what we mean by index is that each of these are stored in this order. And if we want to access any one of them, we can access them by whatever place they are in the list. So numbers 0, because we start at 0 instead of 1. So numbers of 0 would be 2, because 2 is the first element in our list. Numbers 2 gives 6, because 6 is at index 2. It is the third element. One feature that's particular to Python, I don't know any other languages that do this, but I'm sure they exist, but you can also do negative numbers. So if you say numbers -1, we count backwards. So numbers -1 is 10, because 10 is the last element in our array. Hopefully that's clear. Feel free to ask questions if you are confused, but otherwise, yeah, that's generally how that works. And to basically, if we want to do something to all of those elements in the array, what we can do is we can use something called a loop. So what a loop is that inside of a loop, you put code that you want to execute over and over again, multiple times. Why would you want to do this, for instance? Let's say you have an array of things and you want to do something to all of those things. Well, what Python lets you do is that you can choose to loop over every single element in this array. So for name in names basically assigns name to every single element in names. So this would print out hi Chris, hi Kyle, hi Daniel, for instance. So yeah, so name takes the value of every single value in names in order. And then we would just do something to all of those. We have a question. What is this question? Would numbers -2 get something like that? Absolutely, yes. That's how that works. Yep. Okay. So hopefully that's clear. I will continue. And also a thing to note, if you wanted to actually change the value of names, of anything in names, you can't do it with this approach. So name is actually, you can't actually change the value. If you change the value of a name, you won't change the value of whatever is inside of names. If you wanted to do that, you would instead iterate over the indices. So you can iterate over, so what we can also do is we can choose to iterate over all of the indexes in the array. So let me actually clarify what that means. So we have an array called numbers, and we do for I in range 0 len nums. Range is a function that basically gives you a list of numbers from the first argument to the second argument, not including the second argument. So here, len of nums, gives you the length of the array nums. Length is equal to 5. And so if we say range of 0 to 5, that means that we have a range that goes 0, 1, 2, 3, 4. And because this array has 5 elements, that means we get the indexes 0, 1, 2, 3, and 4, which is exactly what we want. And I will take the value of 0, 1, 2, 3, 4 in that order. So, and then we do nums of I plus equals to 1. This means that we take we take a value on the left and we add 1 to it. So nums I plus equals to 1 adds 1 to every single value in the array. Cool. We have questions. Is the array type of the array fixed? Great question. In Python, no. You can actually have any type or any number of types as an array in Python. In other languages, that's not usually the case, but in Python that is. So you could have like a string, a number, a float, whatever. Why you would want to do that, I don't know, but you can. Moving on. We also have while loops. So while loops are what we use in the case where we're not really iterating over an array and we just want to break out if we fulfill some condition. So instead of having values take having a variable that takes different values in an array, a while loop basically lets you run the code over and over again and only exit if we fulfill some condition. So this example is a little contrived, but it gets the job done. We don't have an array here. We instead have a variable y equals to 10. And we only execute the code inside the while loop if y fulfills this condition. So if y is not equal to 2, we'll keep executing this code. So in here, we have another if statement. So if y is negative, we break. Break means you break out of any loop that you are currently inside. So if y is less than 0, you break out. Else, if y mod 2 is equal to 1, so if y is odd, we add 1 so that y becomes even. And then we skip everything else. If y is even, then we divide y by 2. This is integer division, by the way. I should probably explain that. Okay. Regular division, 1/ gives you a float by default. 2 slashes make sure gives you an integer. So if you do long division, double slash, think of it this way. If you do long division, double slash will give you whatever the long division gives, and mod gives you the remainder. So think about it that way. So anyway, what this basically does is that if y is odd, then you add 1, and if y is even, you divide it by 2. Yeah. And then you print every value of y. Take a lot of. Yes. All right, I'm going to move on. So what we can also do is we can make our own functions. We talked roughly about what functions are. They're functions are just, think of them as subroutines. So each function is going to have code inside of it. And if you call it, it will do that thing. And you can specify what it does by like this. So the def keyword is what we use to define functions. So here, as an example, we have a divide function. So def divide AB. And here I've added another if statement here. So if B is 0, we can't divide by 0. So we're just gonna say, hey, we can't divide by 0, and then we have to return something. So we return A. Else we just return A divided by B. And then we can call that divide function just by calling it. So as you can see here, we have divide and we have 2 arguments. So every function needs to have its arguments specified. So divide, in this case, divide takes two arguments, a and b. And if we pass in two arguments, it'll divide a by b, or try to anyway. So here we have divide 12 by 2, and it should give 6.0 because float. And if we divide 3 and 0, well, we can't divide 3 by 0 because we can't divide by 0. So divide will return 3, and it will print, hey, we can't divide by 0. So yeah. If we have no questions, we're going to move on. All right. Okay, so this is just another example that Chris made. So this is a function that determines whether a given year is a leap year. So let me just kind of explain what this does. So we know that a leap year is we know that a year is a leap year if it is divisible by 4, but it is also not okay if it's but not if it's divisible by 100, and if it's divisible by that's so a year is a leap year if it is divisible by 4, but but we don't count a leap year if it is divisible by 4 and it is divisible by 100, but we do count it if it's divisible by 400. It's kind of weird.
It is horrible.
Yeah, but this is basically a function that does that. So if a year is divisible by 4, we first check if it is also divisible by 100, and then we also check if it's divisible by 400. So if it's divisible by 400, then it's a leap year. So we print that. If it's not divisible by 400 and it's divisible by 100, it's not a leap year. So we print out it's not a leap year. Otherwise, if it's divisible by 4 and not divisible by 100, it is a leap year. So we say so. And otherwise, and if it doesn't fulfill all the conditions above, then it's not a leap year. So yeah. And these are just a bunch of things that you could like try out if you wanted to mess around with Python a little bit.
Yeah, this list is essentially like these are things you can do from the things that we've taught you. Like essentially every single thing on this list is something that like has content that was covered, and you don't need anything else. You don't need to like learn anything else in order to do this as of now. So if you just want to practice or get used to like learn a little more and get a little more familiar with Python, you can do any of these challenges. If you want to go further than this, if you go to the next slide, I'll link the slides again because there are a lot of links at the end, but there are more resources like that you can use in order to self-learn. So the first one is Automate the Boring Stuff with Python. It is a book, but it is fully free online. I would very much recommend it. It's very useful and very good for learning practical things about Python and how to interact with your system. The second one is just more examples if you want to get used to, or if you just like see something that's interesting and you want to see how it's done. Third, Google has a Python class that goes more into the technical side of things. We very much glossed over a lot of how Python interprets what you write and how things are written, or like how the system reads your code and the subtle differences between say like is and like equals, the two equal signs, things like that. If once you get further into that, you can do coding challenges, which are just like somewhat difficult. Like they're essentially just problems that you have to solve in whatever language you want. Typically, people do the one they're most familiar with, and it's the type of thing that interviewers do when you try to apply for computer science internships. And the last thing is MIT's courseware, Introduction to Computational Thinking and Data Science, which is also an excellent class for just learning how to apply Python for data science. Earlier, we had a question about Python and bioinformatics, and the way it's used is in terms of like going through a lot of data, making, phylogenetic trees and stuff like that. You can generate those things with Python very easily and very quickly. And when you're doing stuff like bio research, being able to iterate on your code very, very quickly and make changes is very nice and something that is very easy to do in Python. So now I guess that's the end of our presentation. If any of you have any questions or you want us to do anything, go right on ahead. But as of now, we're done. And I guess we should stop recording. Any last words, I guess?
Well, thank you so much, ACM, for presenting on this introduction to Python workshop. As a reminder, the recording will be posted on YouTube within the Idea Center YouTube channel within the next week. So please, again, feel free to review the video once it gets posted. I will also be sending a WISE session survey for just to get more input about the times you all want to have WISE sessions hosted, but also what topics you all want to see more about. It sounded like you all really appreciated this Python workshop. So feel free to share your feedback when I do send out that email at the end of the next week. Thank you again, Chris and Kyle. Y'all did a great job. Yeah, thank you. So I'll be ending the workshop now, but thank you again, everyone.
Yes, I would just like to reiterate that let me post the slides again, but all these resources are linked at the end of our presentation. So yeah, if you have any questions, I guess like ACM has the Discord server and plenty of people are willing to give input and help.
Yeah.
So yeah.
Join our Discord at acmurl.com/discord. It is a fun place to hang out.
Yes.
Okay.
Anyway, we have some questions, so we can answer them.
Oh yeah, go ahead.
Someone asks, what is the difference between programming languages and their usual uses? That is a great question. So that really depends on like what kind of project you're working on. Technically any programming language can be applied to any purpose that you would want, but some languages are obviously better suited to different things than others. For example, take like web development. You absolutely can make web apps in Python, but because JavaScript is sort of designed for the web per se, a lot of people use JavaScript. Most people tend to use like JavaScript for like web development. But yeah. Also, if you're working with hardware, for instance, you definitely want a language that can get closer to how hardware actually works. So like C, C++. But like I said, it can be done in Python. Just a couple of examples. Can someone explain how to reverse a string?
Oh, that was one of the examples. So I guess I'll answer live. It's so you can think of a string like an array, and in our example where we went through loops, you are able to we showed that you could go use negative number, or well, someone asked, I guess we didn't show it, but you can use negative numbers as indices to go backwards. And if you have the length of the string, you can just turn it into a negative number and iterate from 0 to negative length to reverse your string, or to print the string reversed. Oh, did we finish answering the programming language one? I guess we could give suggestions on specific languages too. So I guess I'll do that. So Python is very interesting because it's very easy to it's very easy to code and it's very simple. It's very flexible and you can do a lot with it. The problem is that it's slow. It is well, comparatively, like when you make a program or whatever.
Yeah, when we say slow, it's not like too like terribly slow. Like
it's like
you'll still be able to use it for your own purposes, like, and it'll run it'll be good enough for our uses. But like, say we want to make an application that needs to be like super quick and needs to handle like lots and lots of people using it at the same time. Just as an example. Then like small speed differences really start to matter more. So
yeah,
for like enterprise grade stuff, maybe Python would be too slow for that sort of thing, and you'd use like Java or C, for instance.
Yeah, so for bigger, like for things that need to be fast, like let's say you have a database that like has thousands of lines of code that you need to go through. Python is not a great choice because it's not compiled. You have to like Python is reading each line of code and doing something like very slowly based off of that. When you have like 100 lines of code or whatever, you make something, it's gonna go by pretty quick. But like relatively, it's like comparing like a really fast car to like a spaceship. You know, it's the in usability. Like for most people have no need for a spaceship, but you know, like a car is good enough. But when you have something really big and slow, it's quite you are really big, you need to go through data quickly. Like say Google search algorithms, it needs to be fast enough for everyone. What programming language might be best for bioengineering? I would honestly say Python, because I mean, okay, so let's say you have a giant database of say RNA sequences or something like that. And you need to go through it, or you have a what's Nima's research? It's like you have a collection of HIV, and you need to like sort when they evolved, their evolutionary tree, their phylogenetic trees. Python is good enough for that. You care much more about like being able to change things very quickly and easily write this code than speed. Um, uh, it's also in terms of library support, more people are working with Python, so you would probably have an easier time finding libraries that have that fit your needs on Python than on other languages. So yeah, so things like that. I honestly would say Python is very good just in general. You know, it's like it's probably the best like general use language. I think that's funny because I think Kyle and I don't like code on Python the least. We're very much like low level programmers.
I use Python a lot.
You do? Oh, I don't that much. But like the things we're I guess we are comfortable with very low level stuff where you have to it's honestly a pain in the back to write a lot of these things. Python is so nice to code in. But things like C and like assembly, like Haskell, it's not the easiest to make big changes and iterate on your designs.
I would argue that Haskell, that's not really the case with Haskell. It's easy to add stuff. It's just
that's true. Haskell is very much a functional language, so I guess.
Anyway, just as a side note, if you want to like learn more about like data structures and how you can use that for bioengineering, I would highly recommend CSE 100. It's taught by Nima, who is a bioinformatics guy. So a lot of the examples he uses for uses of data structures do kind of lean into like bioinformatics. So if you are interested in that, then if you can, definitely take that course. It is really, really cool.
Any thoughts on SQL or SQL? I think it is a very specialized language for databases.
Yes.
And it's very popular because it's quite old. There are I think with all programming languages, you can like argue that there are better solutions, but whatever works, you know, whatever you're comfortable with. Say like there's this like trap when you first start learning how to program with trying to learn all of the languages. You know, I'm gonna learn like Python, I'm gonna learn C, I'm gonna learn Java, I'm gonna learn Ruby on Rails. You know, it's like, oh, I'm gonna learn SQL and all like JavaScript, TypeScript. I'm gonna like just get okay at all of them. But it is actually so much more useful to find one language and just stick to it and get really good at that one language, because 90% or maybe even more of like programming, like the knowledge you get is applicable to everything. You know, it's like how arrays work, like how data structures work, how strings are implemented, what an array list is, or like how while loops work. Typically, they are essentially the same on all languages, and the only difference is syntax. And syntax is not that hard to learn. Yeah, it's like it's a way of thinking more so than the methodology of creating is yeah. So I guess we're done with that question. Any other questions? Any other comments? We kind of fit that perfectly, like the time. I'm surprised we got that in an hour so perfectly.
Yeah, that's good. I'm glad that you were able to answer the questions in the Q&A as well.
Yes.
Yeah.
Let's see.
Well, I know it is 4:03. So I'll go ahead and wrap up this presentation. But again, thank you all. And then again, this presentation will be posted on YouTube in the next week.
Yeah, thank you all for coming. This
Yes.
was glad to see people coming out.
Mm.
So
Okay.
good luck on your midterms, and
Okay.
yeah, have a good rest of your day. Yeah.
Bye, everyone.
Goodbye.
Wait, we have another question. Where will it be posted? The recording?
It will be on our Idea Center YouTube channel. So subscribe to our YouTube channel. Okay, bye everyone.